quite a tricky question based on the speed of sound and ultrasound and sound traveling in different materials. It comes down to looking at a couple of readings on oscilloscopes. So we've got a diagram, we've got a signal generator that's going to a loudspeaker, and that's getting picked up by a microphone. And here's our oscilloscope that's showing a reading, showing the waves coming through. How many waves are produced in 0.0001 seconds? So fortunately, it gives us the scale on here. So we're looking at how many waves from there to there. So we've got to work out how many full wavelengths. And a wavelength is one peak and one trough. So there's one wavelength, and there's another wavelength, and there's another. So there's a peak and trough is 1, 2, is 3. So how many waves? We have 3 waves. Okay, so how many waves are produced by the loudspeaker every second? Okay, and this is where we get confusion, because people will say, well, surely aren't there 3 produced every second? No. Now, what we've got going on here is we've got 3 in every 0.0001 second. So to work out how many in a second, we're going to have to divide the number of waves by the amount of time. Okay, and that would give us an answer of 3,000 waves in a second. Okay, why are we interested in how many waves in a single second? Well, we're interested in that because this is the frequency. That's what frequency means. It's the number of waves in a second. So actually what we've worked out is that our sound wave has got a frequency of 30,000 hertz. And you need to sort of understand that for the next part of the question. If there's 30,000 waves in a second, so the frequency is 30,000 hertz, then why can a normal person with normal hearing, why can't they hear that sound? Well, to understand that, you've got to realize that human hearing has a limit of around about 20,000 hertz. So if you mention that is the maximum limit of human hearing, that will get you 1 mark. And then by saying, well, this is over that value, that's a higher, we are going into ultrasound, then that gets you the 2nd mark. If you just said that this value is ultrasound or ultrasonic, that would also get you a mark. Okay, and then we've got this strange arrangement where they've got a high frequency signal generator attached to this steel bolt, and it says they're using high frequency sound, so they're using ultrasound to look for internal cracks in a large steel bolt. And we've got this trace, and we can see that again 1 centimeter represents a very small amount of time, and we can see that the sound, they produced a pulse, and we've actually got a couple of pulses back again. So it's asking why have we got 2 pulses? What's happening? Explain what happens to produce pulse A and B. So what's going on is actually there's a bolt and there's a crack here, and our sound pulse is traveling away, and one of the pulses is reflecting back, and the other pulse is hitting the back of the bolt and then reflecting back. So this first journey here is A, and the second pulse there is B. So we're actually getting 2 signals coming back. So to get the mark from this, you've got to explain, well, you've got to mention reflection. That will get you 1 of the marks. So you've got to talk about the sound or the ultrasound, pulse A representing this idea that the sound is reflected off the crack, and then pulse B is the sound being reflected off the back of the bolt. Okay, and then so finally we get to the last bit of the question, use information in the diagram and the equation. So at least they give you a rearranged speed as distance over time equation. They give you distance is speed times time, and we want to work out the distance from the head of the bolt to the internal crack. So what we're actually working out is this distance from here to here. That's what they're asking us to find out. So quite tricky. So we're going to use, we're going to try and work out first what's the time it's taken. Okay, so at least we can just count that off on the oscilloscope. 1, 2, 3, 4, 5 squares, or 5 centimeters, and each centimeter is this tiny little number here. So we can say that the total time is 5 times 0.0000005 seconds. And that comes to 0.1234. There we go. So that's the total time. But, and they do this a lot with the ultrasound questions, that's not the time it's taken for the ultrasound to take that journey there. It's double. It's the time taken to go there and back again. So that's twice the time. The time it's going to take. Okay. So the time it's going to take to get to the crack. So time to get to our crack in the bolt is going to be half that value. So you need to divide that by 2. And that will get us 0.123. Okay, that. Okay, and then once we've got that value, then we can put this into the distance is equal to the speed, which is 6,000 meters per second, times by this tiny little amount of time. And you calculate that and you get an answer of 0.075 meters. Is that a reasonable size for a crack in a bolt? Well, that's 7.5 centimeters. So yes, 7.5 centimeters is if it's a large metal bolt, that is not unreasonable.